Hello, this is Dr. Christy Lukes, your professor for Chemical Engineering 3111. Today for Lab 7, we're going to be looking at systems of nonlinear equations. So the techniques that we've looked at for this were Gauss-Seidel and Newton-Raphson. Both of these are things we've looked at before, but extended to this concept of systems of nonlinear equations. Gauss-Seidel is successive substitution through a series of equations. It doesn't always work, but when it does, it is at least easy. Newton-Raphson does work when all the derivatives exist and you have all the continuity conditions met. But you're going to have to take derivatives of each function you have with respect to each variable in this system, and then align them, functions across, variables down, and then it's these derivatives, or the Jacobian, times these delta x's is equal to negative f of each of those functions lined up to pair with the derivatives. Now, the things that people commonly forget, they forget to do the delta x, that it's not just that you're doing it for an x value, you're doing it for the change from one x to the next. And then also that it's negative f of x. So however you wrote this when you took your derivatives, it's the opposite of that on this side. In today's activity, we're going to be solving a pipeline network problem. Now, these actually are fairly common. I do a lot of work with Engineers Without Borders, and part of what we do is water supply systems. And in those, we bring water in from, say, a well, and then we pump it or let it gravity feed to the neighborhood. But every time you go to a different street or a different house, you're going to have a branch that forms. Now, this is a fairly simple system here. We're going to bring the water in through a single tube, and then we'll branch it off to two different streets. Now, this one will come back, but here we're going to have yet another branch, and then the flow hopefully will join back together before going to the final reservoir that we're going to catch the material in. In Lab 3, we looked at the flow through a single tube. Today, I've used that same pump and then the same tube size, but then connected with a bunch of T's to recreate the flow system shown. You may not be able to tell that in the video. Now we're going to have a second video here that's going to show you how to see this system run. And then we'll come back for a third video for the lab today so that we can talk about how we'll analyze this system. So take a break, go watch that other couple of videos. See you in a little bit.